In this video, I am going to share with you some very important points about cosmic rays. First of all, the question is, what are cosmic rays? Cosmic rays are nothing but the beams of high energy charged particles that are entering our Earth's atmosphere from outer extraterrestrial space. Now the question is, how these cosmic rays were discovered? Because these charged particles cannot be seen with the help of any optical instrument. Regarding discovery of cosmic rays, we shall have to go to history. A charged gold leaf electroscope was left to itself and it got gradually discharged, as if the air surrounding the electroscope is charged. Earlier, the charging of surrounding air was suggested to be due to radiations coming from radioactive substances which are lying under the surface of Earth. But soon this proposal was discarded because the observations were in the contradiction to the expectations. Many more suggestions were given as the reason for charging of atmospheric. Finally, some strong radiations have been established to be responsible for ionization of air in the Earth's atmosphere. These radiations were earlier named as ozone, after the name of its discoverer, who also got Nobel Prize in Physics for this discovery. And later on, these were named as cosmic rays. In this name, the word cosmos means outer space. Because these rays are coming from outer space, so these were named as cosmic rays. Now the next question is, where from these cosmic rays are getting so much high energy? Many explanations were given. The most acceptable theory was given by Fermi. He said that very strong magnetic fields are trapped in huge isolated plasma clouds which are wandering between the stars in our Milky Way and also in other nearby galaxies. Depending upon the extent to which the particles constituting cosmic rays interact with these clouds, these different particles acquire different amounts of energy. Cosmic rays are of two types, primary rays and secondary rays. First of all, let us see what are primary cosmic rays. The cosmic rays beyond the Earth's atmosphere are called primary cosmic rays, and these rays have two components. One is soft component and the other is called hard component. The soft component of primary cosmic rays consists of electrons, positrons and gamma photons, whereas hard component constitutes fast protons, which are about 92%, alpha particles and heavy nuclei. Now let us come to secondary cosmic rays. When the highly energetic fast protons present in primary cosmic rays interact with particles of Earth's atmosphere, then beams of many charged and uncharged particles are produced. Along with these particles, some photons of energy are also produced. These beams of charged particles, uncharged particles, and photons of energy constitute the so-called secondary cosmic rays shower. Below the altitude of 50 km, there are mainly secondary cosmic rays, and when we reach near the surface of Earth, these secondary rays have only mesons and electron-positron pairs. The next important point to be discussed here is what may be the source of these primary cosmic rays. It may be our Milky Way, it may be some other galaxies, and also interstellar space can also be the source of these cosmic rays. The source of heavy elements which are found to be present in primary cosmic rays can't be the stars of normal size and normal composition. These heavy elements can lie in stars having very large size and having extraordinary composition. Such stars are named as supernova, which lie beyond our galaxy. The high energy heavy particles are emitted by sudden explosion taking place in the supernova. These explosions take place once in 200 or 300 years. So in the nutshell, we can say the big stars in interstellar space are the main source of cosmic rays. It should be noted that only a fraction of cosmic rays are originating from our Milky Way and other nearby galaxies. Next question is, does the intensity of cosmic rays changes as we go above the surface of Earth? That is, what is altitude effect on intensity of cosmic rays? By performing many experiments, it has been observed that intensity of cosmic rays is different at different altitudes. The graphical representation shows that at altitude of about 24 km, the intensity of cosmic rays is maximum. Above 24 km, intensity is low, and below, as we move towards Earth, intensity also goes on decreasing because of absorption by atmospheric air. Now let us see, is there effect of latitude on the intensity of cosmic rays? As we move from equator to poles, latitude goes on increasing. What is the variation of intensity of cosmic rays with latitude? The graphic representation shows that intensity of cosmic rays is minimum when we are near the equator, and it becomes maximum when we are near the north or south poles. Now, what is the explanation for this graphical variation? To explain this, we shall have to recall a relation for force due to magnetic field on a charged particle. The relation shows that force is given by product of charge of particle, velocity of particle, magnetic field, and angle between velocity and magnetic field. When charged particles constituting the cosmic rays approach towards Earth, different particles have different velocities and different directions, but direction of Earth's magnetic field is constant. It is always from south pole towards north pole. As is clear from the figure, in case of particles approaching the equator of Earth, theta is equal to pi by 2, and so the particles approaching the equator will experience maximum magnetic force, that is, their trajectory will be most diverted and it will give rise to minimum number of particles reaching the equator site. Similarly, in case of particles approaching the poles of Earth, theta is 0 or pi, so these particles will experience minimum force, that is, their trajectory will be least diverted. It will give rise to maximum number of particles that reach the north or south pole site. Thus, it can be concluded that intensity of cosmic rays goes on increasing as we move from equator towards poles of Earth. Thanks a lot. I expect comments from the viewers and I will try to respond to those comments also.